we are going to start 1D motion. Okay, maybe in 1 or 2 shots we will complete this chapter. Okay, without wasting the time, I am starting the chapter 1D. So first, distance versus displacement. Okay, like suppose a person started from the point A, he goes from A to B and again from B to C. Now this is 3, this is 4. Now someone asks what is the distance. So distance is total length which the person has covered, total length. So A to B 3, 3 plus 4, 7. So distance will be, so if I talk about distance, so this will be 7 units, correct? 7 units. Okay. But in the same case, if someone asks what is the displacement, so displacement, what we have to do, you have to connect the initial point and final point and see the distance. Like you connect this A with C. So this distance you have to see. So this is 3, this is 4, you know, by Pythagoras theorem, this will be 5. So if this is the question, my displacement will be what? 5 units. So displacement is the shortest distance between 2 points. Between 2 points. Okay. So distance we have to cover all the length, and displacement just join the initial point with the final point and see how much distance it is coming out. Okay. Write fast, very fast. Okay. And if you know these things, you can ignore. If you know and you remember also, then you ignore. So okay, next. Like suppose if I take one circle kind of thing, this one. So R is the radius of this circle. A particle starts from here. I think this I have done already, but still A, this person goes from A to B to C. From A to B to C. So this is the journey A to B to C. Correct? So they will ask, if the person goes from A to C via path B, means A to B to C, what is the distance? How much distance this person is covering? Radius they have given R. Okay. So you know that this complete circle is 2 pi r. This complete circle length will be what? 2 pi r. If I break in 4 parts, so what I can say, these 4 parts, the length of all the 4 parts is 2 pi r. Correct? The length of, this is 1 part, second part, third part, 4 part. 4 parts length is what? 2 pi r. So 1 part length will be unitary method, 2 pi r by 4. But we have 3 parts. Now see, this is part 1 from here to here. From here to here part 2, and from here to here we have part 3. So 3 parts length, just multiply by 3. So 2 pi r by 4 into 3. So this is the distance, because we are covering this distance plus this distance. So this is basically the distance. If they ask what is the distance, so distance is, like now you can solve. 2 1 ja 2, 2 2 ja 4, 3 pi r by 2. So 3 pi r by 2. Correct? So this is the distance. But if they ask displacement, so this is A, this is C. Either you can use that formula 2r sine theta by 2, or because this is very easy case, you can directly write the displacement. If someone asks what is the displacement, so directly join A and C. This is A, this is C. So you can see now, this is right angle triangle. You can see this is right angle triangle. This one distance we have to calculate. So this is R, this is R. Now this answer will be R root 2 R. You are saying na root 2 R. In this case it will be root 2 R. Why? Pythagoras. See na, this is R, this is R. So this distance you write x. So you know that x square equals to this square plus this square. Hypotenuse square equals to perpendicular square plus base square. So r square plus r square 2r square. So x will be equals to root 2 r. Only in this case, not in all the cases. You can write root 2 r. 2r sine theta by 2 is the general I will write. But in this question I am just telling you that the displacement will come out to be root 2 r. Correct? Okay, next. Very important. We have a circle of radius r. You are going from one point, suppose any point, this point, to another point. Means earlier you were here, now you are at here. They ask you that, suppose, okay, in this question you can see that this angle is 90 degrees. Suppose this is not 90, this is 89, this is 88 degree, whatever. This angle is not 90, so this angle I am writing just theta. In general, if I ask what is the displacement, okay, so displacement again, this formula you have to remember, 2r sine theta by 2. This is the formula, 2r sine theta by 2. Now see now, if this angle is 90 degrees, suppose if theta is 90 degree, so sine 90 by 2, sine 45 degree, 1 by root 2. So your displacement in that case will be 2r sine 45 degree 1 by root 2. So this will cancel. So root 2r. Same answer we got na. But if they give 60 degree, so you will apply 60 degree now. You can't write root 2r directly. Root 2r is a special case when theta becomes 90 degree. Okay, they may give that this angle is 60 degree, then what is the displacement? So you have to use this formula. Very important formula. Next, see, always remember that distance is always greater than or equal to displacement. Correct? Distance is always greater than or equal to displacement. In some of the cases you will see distance is more. In some of the cases you will see that distance is equals to displacement. Okay. If I divide here, if I shift this displacement this side, so distance by displacement will be always greater than equal to 1. This also you remember. Next concept, speed versus velocity. Speed versus velocity. So speed basically, if I write speed, so speed is basically how much total distance you have covered by time. So speed, we can write that speed formula, distance by time. However, velocity equals to displacement by time. Displacement by time. This is a scalar quantity, speed. Velocity is a vector quantity. speed is distance by time, velocity is displacement by time. Now one more thing, very important thing, we write speed equals to distance by time or velocity equals to displacement by time only when acceleration is 0, when there is no acceleration. If acceleration is there, you can't write speed equals to distance by time. So these formula only you can write when acceleration is 0, then only you can write. If there is acceleration in the question, you can't write speed equals to distance by time or velocity equals to displacement by time. Their speed, final speed v equals to u plus at. We have 3 equations. Then we use those 3 equations. But if acceleration is 0, we can write this. So again, if I give one question like so there is a body which is at A, it is moving and it reaches B at time t equals to 10 seconds, suppose. Okay, so this is the question. There is a body who starts from A and it reaches B at time t equals to 10 seconds. First question is, what is the speed? Speed. So speed equals to distance by time. So distance, how much it has covered? 2 pi r divided by half, divided by 2, sorry, 2 pi r by 2. Because this total length is 2 pi r, so half length will be pi r. So this is distance by time, that is 10. So this is the answer for speed. Now if someone asks what is the velocity, so velocity will be displacement. So displacement from A, this is the initial point, this is the final point, we will join these two. So this length is what? Diameter, 2r. So displacement, that is 2r by time 10. See, different values we are getting in this case. Okay, now see, again you remember one point, like distance and displacement, here also we have speed will always be greater than or equal to velocity. Speed involves distance, this involves displacement. That's why speed will always be greater than or equal to velocity. Now if I put velocity here, so speed by velocity will always be greater than 1. Magnitude, in fact, if I write magnitude, why I am writing the magnitude? Because sometimes speed they write in the suppose negative direction. Okay, suppose velocity is, in fact not speed, velocity is in the negative direction. So what you will write now? Sometimes you think that okay, velocity is negative, so you will write -4. So minus, for examples, what I am saying, suppose there is an object which is moving this side with 20 meter per second. Okay, 20 meter per second. Now what will happen? Now you will write, okay sir, speed 20, velocity also 20, but it is moving this direction, so you will write -20. Now you will say, sir, if I take the ratio speed by velocity, so 20 by -20 -1, but here I have written greater than equal to 1, so this will be wrong, na? So that's why I have taken, because minus always, I have told already that you should not write minus like this. Minus, you always remember, minus means it tells about direction. In vector we have nothing like minus. Minus is just telling about the direction. So velocity here also, here in this case velocity is also 20 only. You can write -20 I cap, this is fine. But if I ask magnitude, so magnitude is what? 20 only. So this will be 20, this will be 20. So 20, 20, 1. See, it is fulfilling. Because I told this will be either greater than equal to greater than 1 or equal to 1. In this case it is coming equal to 1. Okay. So speed by velocity will always be greater than equal to 1. For that also displacement, here you have written, back I will go. I rubbed. This also you can take displacement, because again you will write displacement minus 5, because you little bit some small mistakes you do now. That's why I am putting this magnitude, that you don't write minus 5, because if you write minus 5, this will come negative, this ratio will come negative. Okay. Next, so difference between distance and displacement is clear, difference between speed and velocity is clear. Okay. Next is average speed, and that's very important. Average speed. Now what is average speed? Speed is distance by time, na? Average speed you just write total distance by total time. So total distance by total time. Similarly, average velocity equals to total displacement by total time. I will give one question. Like there is a person who starts from point A, goes till B with speed 20 meter per second. Now from B to C he changes the speed, and B to C the speed is 40 meter per second. Okay. This distance is suppose 2 kilometer or 2 meter A to B, and B to C distance is suppose 4 meter. Now what he does now, after C he again returns to B. At this CB he returns with suppose 60 meter per second. Speed is 60 meter per second. You understood the question? Means here to here 20 meter per second, here to here 40 meter per second, then here to here back 60 meter per second. Okay. Now they are asking what will be the average velocity. So average velocity is total. First you write, whenever you get this kind of question now, never ever you solve like this 20 plus 40 plus 60 divided by 3. No. You stick to the formula. If you are doing 20 plus 40 plus 60 divided by 3, this will be wrong. We have a proper formula, na? Average speed, average velocity. So average velocity, total, I will write here total displacement by total time. Now displacement if I see, so this person started here, from here, and he ended the trip here. He went there and he came back. So final position this now. So total displacement is what? 2 meter. From here to here, this is what? 2 meter. So total displacement 2 meter by total time. Now time you have to calculate. See, A to B, speed is given, distance is given. So time you can calculate that time equals to distance by speed. See, suppose in order to go from A to B it takes T1 time. In order to go from B to C it takes T2 time. Again in order to come from C to B it takes T3 time. So total time will be what? T1 plus T2 plus T3. T1 plus T2 plus T3. Now always remember these things. See, speed equals to, suppose speed equals to distance by time. So time I will shift there. So time equals to what? Distance by speed. Time equals to distance by speed. So A to B journey, if I calculate time, that is T1. So distance is how much? 2 meter by speed. Speed is how much? 20. So 2 by 20. T2, again time, distance 4 by speed 40. Again T3, distance same 4, because when it is returning same distance now 4, but now the speed is 60, 4 by 60. Correct? Now you can calculate T1, T2 to T3, whatever you are calculating, put here, you will get the answer. Okay, so this is the process. Never forget the basic formula, that total displacement by total time. Now in most of the questions, or in some questions, what I will say now, if you go through the PYQs, what you will see, that they are not giving the data like 22, rather they are giving V1, V2, and there you confuse. Don't confuse, we have the same process. Suppose they are not giving any data like 20 meter per second or 30 meter per second, but they are giving V1, V2. So you solve the question like that. Like one question I will take. See, so a person is going from A to C, suppose. What they are saying, first half of the journey, first half of the, means if this is a total journey, so first half means here, distance wise first half, means half of the distance, it is traveling with 10 meter per second, or okay, I will write V1 with V1 speed. Okay, and this from B to C, it is traveling with V2 speed. Okay, so half of the distance it is traveling with V1 speed, the next half it is traveling with V2 speed. Okay, they are asking that, okay, from A to C what is the average speed. Okay, from A to C what is the average speed. So if they are asking average speed, so average speed, total distance by total time. First you write this formula. Now total distance. Now suppose, because they have not given anything in the question, so A to B, suppose I write x, so B to C also x, same distance now, so x, x. So total distance will be what? X plus x, 2x by total time. Total time, again same thing, time equals to distance by speed. Time from like A to B, it is T1 suppose, time from B to C is T2. So total time will be what? T1 plus T2. So total time, again I am writing T1 plus T2. So 2x divided by, now what is T1? Time equals to distance by speed. Distance is x, speed is what? V1. So distance by speed plus T2, distance, that is x, by speed V2. Now see how we proceed. Now see the mathematics. This is physics is still here. Now 2x you write here, x you take common, 1 by V1 plus 1 by V2. Correct? X cancel. So 2 divided by V1 V2, you take LCM, V1 V2. V1 is already there, V2 you have to write, V2 into 1 V2 plus V2 is already there, V1 you have to multiply, we have to multiply V1 so that you get V1 V2. So V1 multiplied by 1 V1. Now this will go up and this will be down only, so our final answer will be 2 V1 V2 divided by V1 plus V2. If someone is having problem in this LCM kind of thing, so you come to me later on, okay? I will tell you, I will take some 2-3 more cases, so that you don't have, you don't face difficulty in the time of exam, final exam. because these questions are really easy questions. The thing now, they have used variables and there you get stuck. And this is quite normal. If you are thinking now that if I don't know this, what sir will think, I will not think anything, okay? Because one day I thought I told now, one question was there, 8 minus 5 equals to 3 and 7 minus 4 equals to 3. So one student asked me this 3, how they are same? Because this is 8 minus 5, 3 and this is 7 minus 4, 3. So this is difficult only for you people. So if anyone is having trouble in this kind of question or this kind of solution, you come to me, okay? Okay. Again, one more thing that I want to tell you, that mark it important. Suppose an object is moving from here and the object reaches here. It started at t equals to 0, it started from here, point A, and after some time it reaches point B. And this object is moving with constant speed. Constant speed means its value, it is not changing, okay? So speed is constant. Speed of the object is constant. Means you can assume, suppose this object, this is a car or anything, and chima, whatever. So this is moving with 10 meter per second, so 10 meter per second, it is not changing the speed, 10 meter per second. So they ask that if the object goes from A to B, what is the change in speed? So first question is, what is the change in speed if the object goes from A to B? So here also the speed, because speed is constant now, you just assume that 10 meter per second, here also 10 meter per second, here also 10 meter per second. So change in speed is what? 0. Change means final minus initial. Final also 10 minus initial 10, 0. So this will be 0. But if they ask what is the change in velocity? Change in velocity, okay, when the object goes from A to B. This is the 8th time I have asked this question. 8th time, okay, change in velocity. So change in velocity, like, okay, here you give any speed na. Suppose any speed you give, like v. Suppose the speed of the object is v or 10 meter per second, okay. Suppose I take v or 10 meter per second, whatever. I am telling you with common v. So change in speed means, change in velocity, sorry, change in velocity will be what? Final velocity minus initial velocity. I told whenever they are asking na anything which involves a vector quantity, be careful. Velocity is a vector quantity, yeah? Correct? So final velocity will be what? See, the direction of motion is like this. So at B, direction will be what? Here. This I told when I was teaching basics. It is going in this direction. Suppose the particle is going in this direction. This direction they have given, anti-clockwise direction. So at point B, if you say that what is the direction, so this will be what? West direction minus I cap. So final velocity I can write, value is V, because this is not changing, but direction is what? Minus I cap. This is the final velocity. Clear? Value is V, but direction is minus I cap. Minus initial velocity. So initial velocity value is V only. Value is not changing, but direction is what? I cap. So value is V only, but direction is what? I cap. Now minus V, so minus 2V I cap. So change in velocity, what you can see, minus 2V I cap. Now minus I cap is just telling the direction. Change in velocity, if they ask what is the value, how much it is changing, okay, means they are asking the magnitude, that how much the velocity is changing. So it will be what? 2V. Means if we are taking, if in the question they have given 10 meter per second, so if the object is going from here to here, they are asking what is the change in velocity. So our answer will be what? 20 meter per second. Correct? 2V, 2 into 10. 20. Okay. Now we have a direct formula also for this. That if we have a circular motion kind of thing, and if the speed is constant, see what are the conditions. If the speed is constant, means value it is not changing. Okay. If they ask, like suppose earlier you were here, now after some time you are here. Earlier you were here, t equals to 0 at A. After some time you reach point B. This angle is suppose theta. So if they ask what is the change in velocity, see if change in speed they ask, so 0, because speed is constant. So if they ask what is the change in velocity, so same formula like displacement. So change in velocity will be 2v sine theta by 2. Okay. Means if they frame the question that a body is doing uniform circular motion, uniform speed is constant, its speed is, they have given, speed they have given 10 meter per second, and this angle is 60 degree. Okay, this angle is 60 degree. So what will the change in velocity? So change in velocity will be 2v, so 2 into 10 20, 2v, 2 into 10 sine theta by 2, so sine theta is 60, so sine 60 by 2, sine 60 by 2, sine 30, sine 30 1 by 2, 2 cancel, so 10 meter per second. Okay. So change in velocity you can't write directly 0, the 10 10 0, no, it is a vector quantity. And this is not only in velocity, in all the vector quantities you have to be careful. Again I am saying, in all the vector quantities you have to be very careful about the direction. Okay, direction is very important. Okay, next. Now if in the question you get acceleration, if in the question acceleration is mentioned, correct, or you feel that there is acceleration and acceleration is constant also, constant means acceleration is not changing, like acceleration equals to 4, constant na. So acceleration is there and acceleration is not varying, basically acceleration is constant. So we have three equations of motion. So first is v, that is final velocity equals to initial velocity plus acceleration into time. S equals to ut plus half at square. This is the distance. Third, v square minus u square equals to 2as. So these are the three equations. How we have to take the direction I will tell. Question I will take, then I will tell. One more equation is there. Distance covered in nth second. So distance covered in nth second. So what is first, you should understand what is distance covered in nth second and what is the difference between these two, you have to understand. Okay. So suppose like you started the journey from this point, this is A. So this is at t equals to 0. So you were here at t equals to 1 second. You were here at t equals to 2 seconds. You were here at t equals to 3 seconds. And you were here at t equals to 4 seconds. Correct? I can name the points also C, D, E. Now this distance S equals to ut plus half at square. This is the distance, total distance. Like if they ask now, how much distance the body covers in 3 seconds. So if they ask distance covered in 3 seconds, 3 seconds. So the answer will be A to E. Total distance, how much you have covered in 3 seconds? So A to E. So our answer will be A, E. And we will use this formula. S equals to UT plus half AT square. But if they ask distance was covered by the body in third second. So third second means between the distance between the end of second and third second. Correct? So this basically this is the distance covered in the third second. Okay, so third second means between t equals to 2 to t equals to 3. How much distance you have traveled? So this basically answer will be what? D, E. See, the answer is different. Correct? So the distance covered in third second will be like at t equals to 2 and at t equals to 3, whatever distance you see now, that is the distance covered in third second. So what is the difference? So here they are asking 3 second and here they are asking third second. So whenever you see the third second, second second, fourth second, fifth second, so here you have to apply this formula. Distance covered in nth second, u plus a by 2, 2n minus 1. So this is the formula. U is the initial speed, A is the acceleration, n whatever nth second they have asked. So 3 seconds if they ask means total 3 seconds. But third second they ask means from end of 2 second to end of 3 second. How much distance it has traveled. So this is the third second. So what we can write, see, can I write like this also? That this distance is equals to this complete distance minus this distance. Can I write? This complete distance minus this distance will be what? This distance. Now what is this complete distance? Distance covered in 3 seconds. What is this complete distance? AE is what? A is the distance covered in 3 seconds. So can I write distance covered in 3 seconds minus this distance is what? Distance covered in 2 seconds. Okay. So S3 minus S2 means this formula what I can make, S nth equals to one more formula you can make like S third was S3 minus S2. So S nth will be Sn minus 1. First you write, I will again tell you. See what I am saying. Like distance covered in, suppose I ask 8 seconds for example. So you see the data, what data they have given. So suppose they have given initial velocity, acceleration, then you use this formula u plus a by 2, 2n, n is our 8, s to 2n, so 2 into 8 minus 1. Now if you see that acceleration and all they have not given. So what we can write, distance covered in 8 seconds equals to distance covered in 8 seconds minus distance covered in just previous 7 seconds. Total distance covered in 8 seconds minus total distance covered in 7 seconds. Okay. So that I am saying that distance covered in nth second equals to distance covered in n second minus distance covered just n minus 1. So this is also important. Okay. Direction, whenever you are using this formula that v equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as, how we take direction? Like you see where the motion is happening. In the direction of motion you take everything positive, opposite to the direction of motion you take everything negative. Means, for example, see, you can write one statement: in the direction of motion, in direction of motion, everything, take everything positive, take everything positive, correct? Like for example, you throw any ball, this is the ground and this is the ball, you are throwing any ball up, correct? So direction of motion is up, na? Means up direction should be positive, down direction should be negative. Now if I ask that you are throwing any ball, what is the initial speed? So initial speed, see, direction of motion is this, na? So speed is also in this direction, so it will be what? Positive. If I ask acceleration, so acceleration, you know, if you throw any ball, acceleration will always be g, but g always acts downward. Now direction of motion is upward, g is downward, so g is against the direction of motion, na? If anything is against the direction of motion, you take negative. So g you will be taking minus g, correct? So here your acceleration you will take minus g. So if you have to write any equation, na, any equation you choose, like v equals to u plus at, suppose v equals to u plus at. So see, like for this example, like ball goes till the maximum height, okay, means from A to B. So final speed will become 0. You know, if you throw any ball, it goes and stops for a moment. So what we say, final speed becomes 0. Initial speed 0, u, acceleration minus g, so u minus gt. Tomorrow we will continue from here, but just I am telling the direction. And suppose in the same question, the ball is now, see, the ball goes to the maximum height. Now it is coming down. Now the ball is coming down. So see, if I say that u, so direction of motion is this. Like if I talk about this journey from B to C, if I talk about this journey from B to C, so initial speed what? 0, because the ball stopped for a moment, na? So initial speed will be what? 0. If I say what is the acceleration, so acceleration is always g. Now plus g or minus g. Now see, direction of motion is down, gravity is also down, so it will be what? Plus. Okay, so if you have to write this equation, v equals to u plus at, so it will be what? Final speed equals to 0 at gt. Correct? So first select the direction of motion. Along the direction of motion, everything you take positive. If anything is against the direction of motion, you take it negative. Like you are throwing the ball up, direction of motion is what? Up. But g is what? Down. G is always down. So this is against the direction of motion, na? So this will be negative. So g will be negative. But now from the top, ball is coming down. So direction of motion is down. G is also down. So it will be what? Plus g. Okay. Now next, like tomorrow I will complete this chapter. Okay. Okay. Thank you.